doing some stuff related to subassembly as well.
Nice, nice. We are live. So hello, everyone. Apologies for the slight delay. I was telling Dustin I was just finishing up my last coffee about 10 or 15 minutes before seminar, and I was like, oh, I need to make another coffee before seminar. So I had to get that in, and so that's why we're running a little behind today, but really, really excited to chat today. So this is Substrate Seminar. It's a weekly online collaborative learning group where we talk and learn about Substrate, which is a framework for building blockchains, mainly for Polkadot-like networks, and it's designed by Parity Technologies. So my name is Dan. I'm a developer advocate with Parity, and today I'm joined by Dustin from Limechain, and I'm very excited about Dustin's presentation today. I won't steal too much of his thunder, but just to give a little introduction to what Dustin's going to talk about from my point of view. I spend a lot of time in seminar and in general when I'm talking about Substrate, talking about different layers of abstraction. And one of the things you might hear me talk about is Frame is one way of writing a runtime for Substrate that's written in Rust, which can compile down to WASM. And we've written Frame so that it satisfies all these interfaces, and then it compiles down to WASM, and then you get a Substrate runtime. But you can do that with other programming languages that aren't Rust. And that's what Dustin is here to talk about today. And so I think learning about how you can kind of take out a piece from the typical Substrate stack that we use over here at Parity, which is really just one way of doing things, understanding how you can kind of take out one thing. Oh, waiting for Dustin to reconnect. He probably got bored of listening to me talk already. It really helps you understand all of these different pieces. So yeah, Dustin, would you care to introduce yourself and give us a little introduction from your point of view about what you'll be talking about today?
Yes, of course, sure. Thanks for a quick and brief introduction. Hi guys, so my name is Dastan Samatov. I am from Limechain, a Bulgarian blockchain and DLT solutions company. I work as a blockchain developer there since last summer. I'm also currently a senior student in American University in Bulgaria. So I'm majoring in computer science and math. As I've mentioned, I've been part of Limechain since last year, and we do lots of cool stuff here, and including a couple of projects, as Dan have mentioned, from the Polkadot and Substrate stack. During my time here, I have taken part in 3 of our projects related to Polkadot stack. And
Dustin, can I actually ask you a question about your background a little bit? So you mentioned that you're a student right now, and it sounds like you very early on in your career decided to get involved in blockchain. Can you tell me a little bit about why that is, and what interests you about blockchain, and why that's where you choose to spend your time?
I would say I got into blockchain field really randomly. I mean, I am currently doing a math major, and I'm really interested in more in fields of computer science that are more closer to math than actual like coding. I was interested in various fields and never actually knew that one of them was blockchain. So during the first lockdown this year, I wanted to basically start working. So I applied to a bunch of places, and I found out about Limechain, and I got really interested in the blockchain. Before that, I was not really involved in it. I had some idea about like the core points of core points and the part of the blockchain. And I was also taking some classes, math classes related to cryptography and etc. And that was my like background before I started working at Limechain. And like one of the first project that I started as a software developer was I'm going to discuss it later in the seminar as well, was a proof of concept substrate runtime that's basically written in assembly script and runs in Substrate node. Yeah, this is pretty much it. And as you mentioned, I'm pretty early in my career, so I might have some I don't know, misunderstandings. No, not misunderstandings, but some
different ways of looking at things, which I think is good. I mean, yeah, like, look, we're in an industry where like our rock star Vitalik, he did what he did when he was like 19 years old. You know, I'm so excited to chat with the younger people. I'm older than I look, so excuse me when I talk about young people like they're these little whippersnappers. So yeah, I think that's really awesome, and I love hearing about what it is that interested you about blockchain, because one of the things that I like about blockchain is it's such a multidisciplinary field. It's not, just like object-oriented programming or even something like big data, like blockchain is very, very multidisciplinary. You have the cryptography side of things. You have the normal like application programming side of things. You have the community side of things because you need the validator network and the community running the nodes and everything. So yeah, it's very cool to hear about your individual take on it, and I'm very, very excited to hear about what you're doing at Limechain. So please continue.
Thank you, and I completely agree with you. As part of today's seminar, I will be talking about the projects related to Polkadot stack, and as I've mentioned, I was working as a core developer in 2 of them. Again, aside and rather an important note is I'm really early in my career and I haven't worked that much like as a Substrate developer or like didn't get involved in Substrate that much, but I have general idea and I have used it not couple of times. I've used it relatively oftentimes. So then I want to start sharing my screen.
And
yes.
don't let Dustin undersell himself. If he implemented a runtime, he's a lot better than me. Let's just put it that way. So I'm really excited to see what you got, and we can see your screen. It looks perfect.
Yes. So this is the current agenda for the seminar, and Subsembly is like quick introduction to Subsembly. It's a tool, a framework.
If you could increase the size of the text on the screen, please, and maybe even if it's possible for if this is publicly viewable, if you could share the link with people, I think they usually like that. Okay. And if it's not public, that's okay. We can take care of that later. But for now, maybe if you could just press like Command plus, I think that may make the text bigger.
Yes.
Yeah. And then one thing, thank you, that looks great. One thing I forgot to mention, guys, if you have questions about anything that Dustin is talking about today, use the Ask a Question box down there at the bottom of the screen. And that way I can help moderate the questions. Maybe just make it a little bit bigger, Dustin, and then I think we're good to go. Thank you.
Cool. So as part of the seminar, I want to start from the demonstration of Subsembly runtime that we are currently working on. I will be running it on a Substrate node, and I will be connecting it to the Polkadot interface. And one of the reasons I want to start with a demo is I think it's important to give a big picture in the beginning, like actual demonstration and how it is working, and discuss the details and like how we achieved for this conclusion for the result after the demonstration. And it will also be helpful for me later on during the seminar to refer to some points from the demonstration. So I have a fresh forked version of Subassembly, and I first built our. I think this is also needs to be yes. So I first we have a make file where we build the runtime. So this is basically, I will explain later on, but these are like the commands to start building, compiling the runtime and running the node.
And maybe while you're waiting for this to happen, Dustin, can you talk a little bit about what is a runtime?
Oh, so sure. Just a sec. Runtime in a substrate. I guess in a substrate frame, runtime is a part of the node works the part of the node, and it's basically a business logic of the node. So and it helps. So basically, whenever there is some queries or some sorry.
I think you really nailed it with business logic. I mean, there's a lot of different ways that you can kind of like, it's block processing, or you can think about it all different ways. But at the end of the day, the runtime is where you implement your application business logic, and
Yes.
kind of all the other parts of the blockchain. All that they exist to do is to make it so that the results of that runtime computation are decentralized consensus amongst all the participants in the network. But the runtime is where the application happens. And so you can use, for instance, with a little bit of work, and I think this is what Dustin is going to have, what he's going to show today, is take the Substrate node template, for instance, but instead of using the template palette and all of these things in Frame, you use a completely different framework written in a different programming language to write the business logic that then runs inside the little machine that does the decentralized consensus stuff. So just want to make sure we're all on the same page here. And so Dustin's about to demo this. Very exciting.
Yes. So sorry about this, but runtime, in my understanding, as I've mentioned, is a business logic of the application, as Dan have helped me out as well. It's a business logic, and it basically is responsible for carrying out all the instructions that is coming from the outer world to the node. So like it could be an RPC call, or it could be an extrinsic that is sent through the RPC call, and runtime basically takes the call or extrinsic that's incoming from the outer world, and then carries out the necessary logic as it's as it's written, and then after it's basically it carries out the logic, and it's reflected in a state transition of the node. For example, extrinsics is incoming to the node from the RPC call. Runtime receives it and does the necessary validation logic, and then applies the extrinsic, and the changes are reflected on the node. So, like, extrinsic is included either in the block or it's discarded. So, this is my understanding of runtimes, and as you have seen, our node is running with the runtime. And first thing I need to do is now insert the Aura keys. And as a Substrate node, we are using a Substrate node template. We have modified some of the stuff in the node so that it uses only the Aura consensus. And another note we have is basically there is no finalization of the blocks here, so it's only using Aura as a consensus engine currently. And as you see, our node is connected to Polkadot JS interface, and we can see, like, first of all, the block production, and we can see extrinsics that are included in the block. Currently, there is only a timestamp and the logs and seal and etc. And I will also show.
Dustin, let's take a step back and talk about Aura for a second and kind of dig in there. I think that's a good thing to talk about. So this is the block authoring logic. And
Yes.
It's, this is also very involved with consensus, deciding which blocks get authored and who authors them. This is kind of the core of what consensus is all about. And Aura is a proof of authority type of consensus mechanism, which means that in the runtime, in the chain spec itself, you expect a certain well-known set of authorities that you know beforehand. It's not decentralized at all. It's very centralized in the sense that you know this well-known set of validators. You plug them into the chain spec, and then what Dustin did when he started up the node is he inserted some keys into the node of his key store, or into the key store of his node, so that now he can tell the network, like, hey, I'm this quote unquote person that is programmed in the chain spec because I have the private key associated with that public key. And so this is a relatively simple consensus mechanism, but you're like right now, Subassembly only supports Aura, it sounds like, and you're working on implementing more flexible consensus mechanisms, which makes a lot of sense. That's exactly what we did here at Parity.
Yes. So since we this Aura consensus, as you have explained it perfectly, we've decided to use Aura consensus in the first place because it's like the simplest consensus engine that we can use. And for now, we only support Aura, and like Bape and Grandpa consensus engines are going to be included in the next milestones. So for this demonstration, yes, it's just Aura. And should I continue with?
Actually, your colleague Daniel, he answered gave a really nice answer to a question there in the troll box, and I think it bears like reading aloud. Someone asked, like, can someone just give me like a 1-sentence summary of what's happening here? And Daniel said, Dustin is showing a Substrate alternative for developing runtimes. Instead of using Substrate or Frame to develop the runtime in Rust, you use Subassembly and develop your runtime in assembly script, which is a language that's very similar to TypeScript. So what's on Dustin's screen right now is Polkadot JS Apps UI. It's a front end for connecting to a Substrate node. And normally here at Seminar, we would be connected to a node that's running a frame-based runtime, which is a runtime written in Rust that's then compiled down to WASM. But Dustin is running a node that's not using a frame runtime. It's using a runtime written in assembly script, which is what he's here to talk about. So back to you, Dustin.
Thanks, and thank you, Danny. So I wanted to first demonstrate and then talk about the implementation and then etc. and like about what's going on here. But I guess there was some kind of confusion, for which I apologize. But I will continue with the demo, and the next thing I want to show is querying the storage. So as you see, just like any other runtime that was built using Frame in Rust, we can here also we can here query the storage for the balance, for example, and like for timestamp now or etc. Any palette that's included in our runtime can be queried according to their storage entries. So I want to now send a simple make a simple transfer from Alice to Bob. As we have mentioned, like Subsembly, like the current runtime is a simple account-based runtime using Aura consensus, and it currently supports basically transferring like some amount from Alice to like from any source to destination. So I will currently just demonstrate, like, let's say I will give this some value and send it to from Alice to Bob. And okay, so it was pretty fast. And in order to check if it was included in the block, we see that it's actually in the block when like looking at the block's extrinsics, there is balances transfer included successfully in the block. So this was and we can like go on and make sure that the account was actually the transfer was actually reflected on the accounts. So this was a very simple demonstration of Subsembly built runtime that's running on the Substrate node. So
I just want to take another second just to make sure that people are really understanding what's going on here. So Sam, who's my good buddy from Element, I love Sam. He's asking some questions about like, you know, really help me understand what's going on. And so I'm saying that you guys implemented the Substrate runtime interfaces in assembly script. So when we're talking about the runtime, think of it as like this inner state machine. And so what Dustin just demonstrated is very impressive for two reasons. One reason is because they implemented the inner state machine itself in assembly script. But not only that, they implemented the interfaces that allows that inner runtime to communicate with the quote unquote outer node. And then do all this block processing logic so that after the extrinsic was executed, Dustin was able to go back and query the blockchain and see the results of what happened. So it's not just the inner state machine that was implemented correctly. That's impressive in and of itself, but the interfaces with the outer blockchain node have been implemented, and that's the real magic, I think.
Yes. So thank you for everyone, Dan and Daniel, for helping out here. So again, I guess I will repeat it again. We're building a runtime using assembly script. We are building Substrate runtimes using assembly script. And the core thing that we need to know here is basically WASM. So every Substrate runtime is compiled to WASM. It makes it easier for runtime upgrade, and that's why. Basically the connecting part between the Substrate and assembly script is WASM. So which means assembly script also compiles to WASM. So we are implementing Substrate runtimes using assembly script, and our runtime is entirely like completely written in assembly script. So after the demonstration, I want to talk about like the projects we have been building for the Polkadot stack. And the first project that I have to mention is assembly script proof of concept runtime. It's an account-based Substrate, a proof of concept runtime, and it was the first step of our of Subassembly. It laid the foundation. It was like a research that we have been like doing, and just wanted to start with the runtime development and assembly script and see if we can actually build and run it on the node. And quick note, it was also presented in Sub-Zero conference by my teammate Daniel. And most of the stuff why we're building an assembly script was explained in the chat. So again, I will repeat it. Like assembly script is very similar to TypeScript, and it, as you know, most of the web developers, most of the developers or programmers, they are familiar with JavaScript or TypeScript-like languages. So building runtimes, Substrate runtimes in assembly script will enable other developers, more developers, to be aware of Substrate and basically boost the popularity and availability of the framework. So yes, the next one is, I guess I will have to talk about also how we started with the Substrate proof of concept runtime. When we first started building it, when we started obviously by implementing the runtime API entries that are exposed from the WASM encoded, WASM compiled binary. So, for example, like there's core initialize block or Aura API authorities. These functions needs to be exposed from the WASM so that the outer node can call these functions and get whatever the node needs. Like, for example, core initialize block receives the arguments from the node, like block arguments, and it needs to initialize. It needs to set necessary storage entries, populate the necessary storage entries, and make the environment, make the runtime environment ready for block initialization. And Aura API authorities, for example, it's another function that is exposed from the runtime. Basically returns the set of authorities, the vector of authorities that are validators in a given runtime. And as Dan explained before, Aura consensus gets the authorities from the chain row spec. And yeah, so the next, if anyone has questions, or like if anyone wants to see the source code of this Substrate or runtime, I guess I can leave the link of the GitHub repo. Here. So yeah, so this was our first second project as part of Web3 Foundation or a general grant program, and it was basically the foundation of the Subassembly. It was like we gained a huge, like very huge insight from building this runtime, and we basically carried like we are basically using most of the code that we have written as part of this project in our newer Subassembly project. The next project is assembly script implementation of Substrate scale codec library. It's integral part of each of the projects. The first one and the Subassembly core, it's like integral part, and it's used and it's used extensively since we need to have some kind of we need to have the same encoding and decoding in the runtime, in our runtime, and from the node side as well. So yes, and we the next step is the next logical step after the runtime was coming up with a framework that will help developers to easily generate or write Substrate runtimes not using Rust or not using Substrate. But it rather sounds ambitious because Substrate is, I would say, very sophisticated, and like it would be very hard to implement, like fully implement it in assembly script. And I will now list the reasons why we are at this everything eventually. Cool. Okay, so people are discussing Rust and assembly script. Anyway, I will now list the reasons why we are building subassembly. As we see in the chat, people are discussing Rust. So I will go on and say that one of the reasons why we are building subassembly is Rust. I would say it's an amazing language. It's very robust and it's very powerful. During the first project, like during our first proof of concept or Substrate runtime, we were reading a lot of Rust code from the Substrate source codes or like node templates. So we were involved. I was reading a lot of Rust code, and I had hard time at first understanding and starting to learn it. So I think for a new beginner, for a learner, Rust is pretty complex. So complexity of the Rust is might be one of the reasons why people might get scared of Substrate. Then?
Yeah. This is I think you can see even in the chat there, Tom is really encouraging you to kind of like dig into this conversation a little bit. I'd love to hear, like, as someone who at one point had to go about like learning how to read Rust, talk about that a little bit. Like, how did you approach that challenge? And answer Tom's question a little bit there, if it feels comfortable to you. How would you compare Rust versus assembly script? What does it feel like to write in one versus the other?
So my biggest experience with Rust was when I had to rewrite the Substrate node to use only Aura consensus engine. I think by default it uses Babe and Grandpa for finalization. So since we weren't planning to implement block finalization in the proof of concept runtime, we've decided to use only one consensus engine, and it was Aura. So I had to rewrite the nodes code so that it uses only Aura. And I thought it would be just simple, remove the code for Babe and Grandpa, but it took me quite a while to actually like make it working. But it was, let's say, I was just beginning to like read and learn Rust, and maybe that's why it took me a while to make the node working. But in general, I really liked Rust because it how do I say this? So most of the stuff that we are developing with assembly script is basically figuring out how to do it in assemblies. So like there are some things done in Rust which looks like a magic. So you see it and it's like just a piece of code, like I don't know, like 50 lines of code, and it does like a lot of stuff like under the hood. But when I wanted to, let's say, rewrite the logic in assembly script, that would have taken me like twice or three more times, like more times lines of code. But at the same time, it wouldn't be impossible. Basically, it would be impossible to have the same functionality as the Rust code. So, like as a comparison, assembly script is very easy to get started, very easy to get started learning. But Rust in this aspect was very hard for me, at least. I think for other learners as well, it's the learning curve is very steep.
Yeah. On January 5th, I can't share the link right now because I'm in Crowdcast, but on January 5th, I did a seminar about Rust syntax for Substrate and talk a little bit about why Rust is the way that it is. It's a systems programming language, and so it's designed to solve certain classes of problems. And just like as human beings, we use like different languages to talk about different problems. So maybe if I want to talk about my thoughts and feelings, I would use the English language because that's how I'm comfortable talking about my thoughts and feelings. But if I want to talk about mathematical problems, I use the language of numbers. It's like a different language that I can use to communicate different types of concepts with people. And so Rust is very much designed to communicate concepts that arise when you're doing systems programming. And so there's all sorts of things that you can do with Rust that are designed around that problem. But if you don't need to solve systems programming problems, it can be very, very complicated and a very high learning curve. And assembly script, it's much more intuitive, but it's not always as easy to know that you're doing something correctly with assembly script. I think that's where Rust really shines, is that if something compiles in Rust and you can run it, you have a very, very high degree of certainty that it's correct. It's not mathematically correct. Rust is not that kind of language, but it's very tight. Whereas with JavaScript type languages, I'm sure we all know you write something in JavaScript and then you run it and it's like, oh, undefined, like anything could happen. So they're different languages. So back to you, Dustin.
Yes, I will get onto that as well. Assembly script has also some like very, very unexplainable behaviors sometimes. So I was discussing the reasons why we started Subsembly, and this was mentioned a couple of times. No, not this one, but I mentioned that Rust might be an entry barrier for some developers. And one of the while I was trying to like modify the code of the Substrate template node, I ran into another issue, which was a build time. So when I had to change a line of code, let's say, or just add some logs or like debugging lines, it was taking me from 1 to 5 minutes to just compile one line of change. Maybe I had some configuration errors or something, but it was usually taking quite a while to compile. So in this regard as well, I think assembly script is like what we are doing now is kind of better than
it's much more
Rust.
developer friendly. It's a better user experience.
Yes.
The Rust compiler, it does a lot of work to guarantee that correctness that we talked about. And so you pay a price for that. It's long compile times, it's not responsive. You know, as a developer, you want to make a mistake and then fix it and see the result very, very quickly. And it's very difficult to do that with Rust. You couldn't ever have something like, you know, like with front-end code, you have live reload servers where you save your code and it automatically compiles it and you can see the changes right there. And that's so nice. It makes developing so much easier. And with Rust, that is very, very difficult. So I really hope it's starting to become clear now why I get so passionate about the work that Dustin and Daniel and the folks at Limechain are doing, because they're making it easier. They're unlocking substrate development and blockchain development for a whole world of other software engineers. The 96% of software developers that don't love writing Rust code, because there are some of us out there, you know, sorry. Okay, back to you, Dustin, promise.
So build time was taking particularly a long time for the Rust. And for our current implementation of Subassembly, like building a runtime usually takes from 10 to 15 seconds, which I think compared to Rust is a good result. So the next reason why we are building Subassembly is, again, assembly script, because there is a common ground, which is WASM, and they are like Substrate runtimes, and the assembly script are both compiled to WASM. So there is a possibility to build a runtime using assembly script. And and the next one is a very like lower entry barrier to enter like assembly script. It's easier for developers to start up. And the next one is, I guess, faster build and compile time in assembly script. And another reason is it's just Substrate is an extremely interesting and extremely sophisticated, generally, project for us. And we had we spent quite a lot of time reading like source code of the Substrate and various implementations, macros, and etc. And we were very impressed with the design, implementation, and overall abstraction, like that's in Substrate. And I would like to give props to Parity developers for that. The next point I wanted to discuss. I wanted to discuss some design decisions we have taken during the development of this assembly. So I have some cool screenshots and graphs of showing, or like that will help me explain myself. And this is the first one, is just basically overall overview of how subassembly is implemented. And as we have mentioned a couple of times, the runtime exposes runtime interfaces that are exported from the WASM code as a module and could be called from the or from the node, from the Substrate node. And another I guess part of the subassembly is configuration. So we have a runtime. I guess I will show the hierarchy folder structure to explain myself. So there is this runtime folder where the runtime folder and runtime TS file, which contains all the types and all the palette configurations that's used. It's very similar to Substrate's runtime folder, where you implement the runtime interfaces where you declare the types that are being used in the runtime, or where you declare the constants of the runtime, and then the storage entries and etc. So this is a place that we are doing the same stuff as Substrate does in the runtime runtime rs lib file, I think. So yeah, we declare the types that are being used. For example, block number type could be like compact int or U64, or like extrinsic type is this hash type, what kind of hash type to use in the runtime, and etc. So it's like very flexible in terms of development. So, and another thing is in the scale codec that I have mentioned, in the scale codec, there is a codec interface. So any type that basically implements the codec interface can be used as a subassembly runtime type. So like whenever there is no implementation of some trait that's in the substrate, it could be just rewritten or re-implemented in assembly script. And the most important thing is it should implement the codec interface, and it can be used here. And we have decided to name like three palettes that are not like, I guess, modifiable or configurable. So system and executive is the same as in Substrate, frame system, and frame executive. Executive is responsible for orchestrating the incoming calls from the node. It calls the necessary necessary steps for block production and block extrinsic validation and etc. So it's basically orchestrating module. A system, on the other hand, is like in frame, like in Substrate. A system is used for actually like communicating with the storage. So it sets the storage entries during the block initialization and block finalization, and basically extrinsic execution. And every logic is like the logic that the logic of communication between the storage and state transition is in the system. And metadata is one of the modules that are auto-generated. So like when we compile the runtime, we have a tool that parses the palettes and basically generates the metadata of the runtime. And it's just plain bytes, scale encoded bytes of metadata. And palettes, we have here like in assembly, there is a palettes folder which contains every palette that needs to be included in your runtime. So whenever if a developer wants, I will see some nice software. Yes, yeah. So in the palettes there is every palette has its own folder with the files that have the same name as the folder. And I can show one example of a palette, how it's implemented. I have an example of a timestamp. This is timestamp palette. I had to cut some of the other functions, but this is basically like overall insight on how it's implemented. So first of all, we declare the storage entries of the timestamp. Storage entry model is a wrapper model for interacting with the node storage. So we initialize the storage entry with the module, and then the module in the entry prefix. So like timestamp now and timestamp did update. So these entries can be also, as I have demonstrated can be retrieved from the Polkadot.js interface. So this first we declare the, sorry, Dan?
So for people who are used to Frame, it looks like what you're showing there in assembly script would be similar to what we see in the decal storage macro.
Yes, exactly. Yep. Decal storage macro, yeah. So, but we have in our plans to further improve this code. I think we're going to use some other description tags that are going to indicate that it's a storage entry, but it's in the later milestones. And the next, so like this, yeah, this could be thought of as decal storage. And every palette is a class in assembly script, and every function, or not every function, but every interface.
Dispatchable.
Every dispatchable of a palette is a static function that receives like the corresponding arguments, and there's like this validation logic and etc., and then it returns response codes like success or failure, and if it's failure, like what kind of failure it is. So this is the brief overview of how the timestamp palette is implemented in assembly script. And most of this is not the whole code, obviously, but this just for demonstration. And so let's say if someone wants to add the any palette, I don't know, some palette like online, I am online, I think there is a palette like this. And like if someone wants to add, let's say, session palette, they just need to implement a class, a session palette, just like similar to timestamp, and then it should also also implement the dispatch functions, dispatchable functions, and etc. And after implementing it, they just need to expose it from the Runtime API as a runtime interface, and also doing the logic. Yeah, I think that's going to be enough to include the palette in your runtime. But again, this is work in progress, so we're still working on it, and it's going to be a lot more easier to add palettes in the future.
Dustin, can I ask a very leading question in my role as Parity developer advocate? Sure. I noticed that in Subassembly, you seem to have really emulated the Frame way of writing a blockchain runtime. And you didn't necessarily need to do that, right? Yes. You could have chosen a different way of thinking about a runtime. Why did you choose to think about things in the Frame way?
Sorry, like, do you mean like this here, for example? Can you like dispatchable functions and the storage entries? I think I need to hear your question again.
Yeah, so basically, as I indicated, I'm asking a pretty leading question. When you and I and Daniel were talking before, I think you guys mentioned that you realized that Frame is a very well-designed framework. Yes. For writing a runtime. And so although you could have chosen to adopt different conventions and ways of thinking about things, you more or less decided to emulate Frame in assembly script because So you seem to believe it is a good way of writing a runtime. So just a way of leading into congratulating the work we do here at Parity, basically.
Yeah, exactly. Exactly. Props to you. It's a very well designed, and at first we have tried to stick to our way of implementation of most of the stuff. We were like, for example, for storing the storage entries, we weren't hashing them while we were storing in the storage. We were just storing it as a byte as just like plain bytes, scale encoded bytes with not being hashed. So later on, we discovered that if we need our runtimes to be able to include it or include it in the for example, just in Polkadot.js interface, there needs to be a metadata, and it enforces some rules about encoding and decoding and etc. So in some ways, it was kind of inevitable, and it was the goal is to make runtimes that could be used in Substrate node, and there are some parts where the Substrate node actually enforces its rules. So we had to stick to the way the frame is designed. Yeah. Okay. The next stuff, as you see here, like this yellow colored stuff makes the development very easy, provides development ease, and this it's not advised to basically change the core or frame logic, but I mean, of course, if you want to experiment or if you want to change some implementation, you could do it in the frame or core, but core is published as an npm package separately, and it contains the most used types of like our subassembly as a library. And yeah, so another thing to note is that every runtime trait that's in Substrate is a model here that implements the codec interface. And yeah, so and the storage module basically provides access to the storage of the node. Crypto module provides some most used crypto functions like verifying the signature, signing the extrinsic, etc. Log is used for logging messages to the host. So the folder structure is here, and I will also share the link for the repo, and you could explore it more there. So I wanted to compare some of the examples of our implementation and how it's implemented in the Substrate. And the first one is like Runtime API interface. As most of you are probably aware, runtime APIs are exposed or implemented like this in Substrate, like initialize block, and it calls executive initialize block with a header. And so this is the implementation in Substrate in Rust, I guess. Yeah, and this is assembly script. What we are building in Subassembly is we have the name of the function similar to here, core initialize block. We have the name, and one thing about assembly script. So every WASM function that's exposed to outside receives the data as a pointer and the length, which is the length of the bytes. And we have some serializing utility functions which like serialize the incoming pointer and the incoming data from the point. It converts the pointer to the bytes, and we have a bytes reader, which is part of scale codec, which decodes the incoming bytes, scale encoded bytes into the type, and we call the same logic from the executive. We call the initialize block, and we supply the header. And
random question: are you guys reusing any of the Polkadot JS stuff for encoding and decoding this stuff, or did you rewrite everything yourselves?
So we're not using Polkadot JS for encoding or decoding the types. we have assembly script scale coded library with the integer types and hashing array types, and we're using extensively our own library scale code, assembly script scale coded library, but in some parts we are using Polkadot.js. For example, for generating the metadata, we parse the codes of the palettes and the system, and then after parsing it, we generate the metadata as a JSON file, and the JSON file is then converted using the Polkadot.js into a metadata instance, and that's being returned for Runtime API Interface metadata underscore metadata. Whenever the runtime interface is called, it returns the metadata as like scale encoded bytes. So this is like, I think the only time we're using anything with Polkadot.js.
Interesting. There's a question in the chat there about sizing of types in assembly script. Do you have any thoughts you'd like to share on that?
Well, I think Wasm has only 32-bit and 64-bit unsigned, right? Or unsigned integer types, but assembly script has up to 64-bit. Assembly size types are as well, but maybe they're a bit more optional. No, assembly script has all the integer types that I know of, like unsigned and signed integer, every type, but it doesn't have 128-bit integers. So we use some external library, big number library for that. So this is the comparison, and there is another comparison for runtime configuration, as I have mentioned. So in Substrate, let's say, in Substrate, when we declare, like in the runtime, we declare the types that are going to be used in the runtime. So like, for example, block number is this, and etc. These are then used in the runtime or in the palettes. And the way we are doing it is pretty similar to Substrate. And as I have mentioned, this is our library scale coded, and we have the most of the types that are in the scale codec: byte array, bytes, compact int, hash, unsigned integer, and etc. So these are basically wrappers to the native integer types with an interface for encoding and decoding from scale encoded bytes. So we basically declare the types like this, and then these types are in turn used in the palettes or in the runtime, in the system, frame system and executive, etc. So like it's easily configurable, changeable. So if someone wants to use any other type for moment or nonce, it could be changed from the runtime file. So this is, and then there's, I guess, another difference is it's commented and it's not commented, but we will fix that later. I have shown the palette example, and then there is another one significant design choice that we had to take, design decision that we had to take. So this is basically a dispatch function. This dispatcher module is generated during the compile time. So when we compile our code, it first parses the whole code of the subassembly runtime, and then generates the metadata. And from the metadata, it generates the dispatcher module, which has a function dispatch, basically based on the call index, just dispatches the call of an incoming extrinsic. and this is one of the differences, one of the few differences from the frame, from the substrate. I guess maybe under the hood it's doing the same stuff as we are doing in Substrate.
Yeah, I think that's actually kind of an interesting point to bring up. We mentioned this term dispatch, and I just shared in the chat there the link to the glossary definition of it. It's kind of an important thing to understand because it unlocks a lot of capabilities of Substrate. So basically, a dispatch is a way of referring to a call. It's like a data type that is a function call, basically. It tells you a pointer to the function and then all the parameters that you want to pass to that function. And the reason that this is very powerful is because with Substrate, you can either execute that as yourself, so to speak, or as in the case of the pseudo module, you can take that packaged up function call and call it as someone else. And this is really, really powerful. And so it's very interesting there to actually see the assembly script implementation of that, because it's pretty evocative of what's going on. It shows you that there's basically just this call data type that you then, it's just a switch statement that you say, okay, it's this call with this arguments and go do the thing. And that's actually a really important part of Substrate to understand.
Yeah, I guess in some ways we're kind of like simplifying most of the stuff that Substrate doing, but I'm glad that it brings some new insight. So this was basically the comparison of how it's done in Subassembly and how it's done in Substrate, and our node is still running, which is good. It should be doing so. The next stuff is the future of the Subassembly. As I have mentioned, we are currently, it's work in the progress. We're working on it, and we're, I think, implementing the third milestone, which is a CLI tool, like similar to Substrate CLI, which basically eases the development of the runtimes. It's going to later on provide wrap the logic of building, compiling, and generating the auto-generated files, and etc. And yes, so challenges during the Subassembly, or let's say challenges during the development of Polkadot stack in assembly script. I would say, although I've mentioned this as an advantage of assembly script, I would say assembly script at the same time is a big disadvantage. So it's pretty young library. It's not mature, but at the same time, it's the main reason why it's possible to build like Substrate-based runtimes in a JavaScript language. But as I mentioned, it's not well covered, and so most of the changes that we have taken, most of the decisions that we have taken that are different from the way it's implemented in Frame were influenced by the limitations of assembly script. One of the few examples of the problems of assembly script is the error messages are very vague. It doesn't say much. There is just one default error message which says runtime unreachable. Something happens and there is this huge trace of errors, but it doesn't say much. Then runtime unreachable error. And in the beginning of the project, it was very hard to figure out where the error was. It was it was hell for debugging and finding the problem, finding the code with the problem. And another limitation is if there are some JavaScript or TypeScript developers, there is no support for closures, and there is no support for like widely used try and catch syntax in assembly script, which again forced us to take some like interesting, I guess, or some interesting decisions that we wouldn't have taken, let's say, if we were developing in TypeScript or JavaScript. And I guess at the same time, it could also be counted as an advantage, because it made our development differ from the way the Substrate does something, and like think about a different implementation, think about more unique side of the assembly, of the subassembly. Sorry.
Dustin, can you go back and show the that awesome diagram that you had with the yellow and the gray?
Sure.
I really like that diagram. And as you're talking about like some of the challenges that you faced with assembly script, and we were talking about like Rust and systems programming, and you have this gray stuff, which is the stuff that you're saying like, okay, you're probably not going to need to change this. This is difficult to change. That's like the runtime system itself, the framework kind of. And then the yellow stuff is like, that's your application logic. That's more of the stuff that like is easier to write in a language like assembly script. But when you try to write more of this system stuff, that's where maybe Rust is a little bit more designed for those types of problems. And so that's why you are kind of highlighting some of these challenges that you ran into. But if you want to provide a friendly application framework, someone has to solve those problems. And as a developer advocate, I really believe that that you understand something deeply when you're able to explain it to someone else in a pretty simple way. And so that's what you guys are doing with assembly script, is you're doing all the hard work of looking at Substrate, understanding how it works, deeply understanding it, and then saying it in a different way that's quote unquote easier for people to understand, and unlocks this whole realm of possibilities for application developers. So obviously I get really excited about this stuff, but that's why, because as a developer advocate, this is where it's at. This is what's making you're doing the hard work so that other people can have a better, easier experience.
Yes, that's a really great insight. I have never thought about what I'm doing in this aspect, like with this angle. It's as you've mentioned, like Substrate was done, like it's impressive the way it was written, the way it functions. It's very hard to match it. So I guess this is one of the challenges that we are facing. Basically, in my view, I think subassembly could be something like a light alternative to Substrate, with the most essential palettes, with the support to most essential palettes. Maybe in the future, like with the support to smart contracts or something like this. So again, this is a work in the progress, and I think there might be some cool new developments in the future. And the next point of my presentation is the future of the subassembly. We envision the future as a framework for building maybe like parachains that could be included in the Polkadot relay chain. We are still kind of researching about this possibility. We're still in the research mode. So it's one of the visions that we have for the future of the framework. So it should be like a fully featured runtime that could be included, production ready runtime that could be included in the Polkadot ecosystem.
And also, correct me if I'm wrong, but this is all open source, right? So there's lots of people watching right now, and maybe some of them are really excited and they want to contribute to this, and that's something that they can absolutely do and should do, really.
Yeah. Yes, and it concludes my presentation. Thank you.
Yeah, that was a great presentation. Do we have any questions?
Yes, Q&A time.
We have a question. Let's see. Thanks for the seminar. It really helps me to understand Substrate. I am just starting with Substrate. Do you have a tip where I can start to get an understanding of Substrate? Yes, definitely. Let me share a link for you. I really like our awesome Substrate repo. This is where I work with the community to try to keep a lot of our resources. And then I also have, this is like an unofficial document that I wrote just to kind of help people understand a little bit more about Substrate as well, kind of reiterating some of the stuff that we said. So I'm glad that this was helpful, and I hope that those resources are helpful for you as well. Any other Go ahead, Dustin.
Substrate recipes are also a great source.
Love it. Love it. Let's share it. I'll get that link. Substrate recipes is like a cookbook for blockchain chefs. And it's a great place to go if you're looking to like, you kind of know what you want to do, but you're not quite sure how to do it. Recipes is a great place to go and find like reusable snippets of code that help you become a better Substrate developer. Dustin, any resources that you want to share for Subassembly or Limechain or any of the stuff that you guys are doing for people who may want to learn more?
I will just leave the links for the Subassembly. It has a great README introduction, which you could basically take and follow the instructions and see if you can tweak something and change some source code.
Less girlfriends, more Substrate. Yeah, I love it. More Subassembly. That's awesome. Yeah. Well, awesome. I mean, I hope that some people like dig into this and guys like build something cool in Subassembly and tell me about it, and then come on seminar and tell the world about it. And like that's exactly what Dustin and I and Daniel and everyone we want to see. So yeah, thank you so much for coming on, Dustin. Any parting words or anything?
Well, just thank you for giving this opportunity to share the work that we are doing, and I think I hope it gave you some insight or some thought-provoking ideas for the future. I hope this was useful, spending of your time. Yeah, that's pretty much it. And again, thank you, Dan, for making everything so smooth. And I really enjoyed my time here. And I will be here next Tuesday.
Nice. I love it. Grow the seminar army. Perfect.
Yes,
and yes, we have a question. You can rewatch the seminar. So just the same link that you're at right now, this will be a recording. Yeah. Yeah, this was definitely very useful, Dustin. This is my favorite part of my week. So thank you for being a part of it, and I'm looking forward to seeing you at seminars in the future.
Sure. Also, thanks to my colleague Daniel Ivanov, who's in the chat as well. He was the brain of the subassembly and everything related to assembly script and Substrate.
Must be the name. Just something about that name. Yep.
Exactly. Sure.
All right, everyone. Thank you very much. Thanks, Limechain. Have a good one.
Ciao.
Bye.
Bye.